Hi guys and girls, this is recapping our noise gate lesson that we've had recently, and to explain what a noise gate is, it's used on all manner of instruments really, but it is commonly used to suppress unwanted noise that is audible when the audio signal is at a low level. So if you're guitaring and you're pretty loud, but when you stop playing guitar, you get a buzzing noise from the pickups, or the microphone's lead is a bit dodgy. It can be used for that, and that's the first sort of example I'm going to use today. I've got a little sample of a guitar, and I'll play it for you now. And you can see where this part is where the guitar cuts out, and it gets a little bit of a ring buzz on the string. And if we just have a little look again, now by putting a noise gate on you, we can get rid of that unwanted noise. And by putting that on, I can just go through a few of the parameters on which the noise gate has. It's got the basics up here again: the bypass and compare and side chaining that we seen last week in on the compressor. It's also it's got a threshold, and another analogy here which I like is sort of, if we think of the noise gate as an actual gate, a garden gate, or more, or even better, a door. Our threshold would be maybe a bouncer, which is telling us exactly how loud a signal has to be before the threshold starts working. So at sort of minus 100 decibels, where the bouncer is literally letting everybody in. Until 0 decibels, where it's got to be anything above 0 decibels or unity is everything below that is not allowed in. So that bouncer is pretty stern. The reduction is a slider which sets the amount of actual signal that's been reduced. And bizarrely, I always found it a bit weird, it's a bit of an oxymoron. You can have plus reduction, so you're actually adding, you can't add and reduce, but you can actually reduce. I'll show a bit about that later. Again, we've got the attack buttons, which is how quick the noise gate is going to come into effect. Hold is how long that door is held open for in milliseconds. Everything is in milliseconds here. And the release is, again, exactly the same as compression, is how quick it's released back to its original output. The sidechain monitor I'm not going to use today, because they got a low and high cut pass, and that's basically if you're using the noise gate for drums. So I can't really give a good example beyond now. The hysteresis is if we just drop this down slightly, what the hysteresis does is actually when you've got the threshold field is really close to where it opens and closes the gate, you can get a bit of chattering on the signal. That's from like the gate opening and closing really quickly. So the hysteresis sets in decibels, it sets a field that sets a difference in the decibels. So it prevents that opening, that rapid opening and closing of the gate. The look ahead is actually where the noise gate looks ahead in milliseconds again, just to analyze the incoming signal which allows the effect to respond more quickly to peak levels. So I'm going to see, we're going to play about with it now and see if we can get the center bit reduced. Now you can hear the chattering a bit now. That's what I mean by chattering. So if we can there now, take it away. And I think I can't hear brilliant on these tiny speakers, but I think that is I've been taking them. It's taking them a little bit away now. Yeah, great. Yeah, and that can be used to take away sort of, like I said, unwanted guitar noises. Usually setting the reduction slider to the lowest value ensures that any sound below the threshold gets taken away completely. Obviously, reducing the decibels takes away less, and like I said, you can actually gain reduction, oxymoron again, which gives the kind of it gives the decking effect that we had last week on when we done the compression. I can't hear that very good now, but well, it does. Yeah, and I think that's about it. I'm going to show a bit of side chaining now, but I'm going to do that in the next video. Thank you.